Hey guys, let's do some homework answers. Make sure you have it out. Okay, looking at this is kind of a weird little situation we got going on here. So the first thing I'm going to do is I'm going to say, if A is off, that means B, C, and D all are all on. So that means A is going to be a separate path. So if I were to draw it, just based on this, I'd say like B, C, D are all in a row, and then A is off to its own side. That way if A goes off, there's still a path between B, C, D. But when B is off, A and C are on, but D is off. So that means that B and D have to be in a line. So maybe it looks more like that. But now, when C is off, the rest go off, which means that C has got to be its own path. Sorry, C's got to be part of the main path. So this is what I get right here, which makes sense. If C dies, they all die. If A goes off, B, C, and D are in line. And if B goes off, D goes off, but C and A are still on. Therefore, that's my picture. I just kind of redrew it like this. Now, C doesn't have to be in front. C could also be down over there afterward. All that matters is it's the only path. Next up, we see this cute little thing right here. So the first thing I do is I draw a picture from 1.50 volts and 6, 7, 11, one after another. Then I make a table. I put in the total resistances, 6, 7, 11. And now since, 1.5 volts. Since they're all in a line, that means you just add them up to get the total. That's what the thing about the series circuits is. I get 24 ohms. Do V equals IR, solve for I, and you get 0.0625, which is the total current of the circuit, and it's the same for each of one through them. Because in series, they all have the same flow. If a battery had 5 coulombs, that's Q, how long would it last? Trying to find time. Current is charge over time. So time is charge over current, which if you do the math, you get 80 seconds. Now, for how much voltage is across the 6 ohm, I know that voltage drops. The total voltage drops to go 1.5. Because of that, the most has got to be for the 11, the least has got to be for the 6. Because in series, to have the same flow, you have to have the most push, the most resistance. Do V equals IR with I and R, and you get 0.375. Now, if you're to switch the 6 to a 5 ohm, the resistance goes down, which means the current's got to go up. So the total current's going to increase. And finally, which resistor is most powerful? I have a couple equations to choose, but since they all have the same current, I'm going to do I times I squared R. Since they all have the same I, the only thing that matters is the resistance, so the most resistance is going to have the most power. The 11 ohm bulb is going to be the strongest. Number 3, I'm going to do the same thing this time they're in parallel. I'm going to redraw my picture again. Since they're in parallel, however, going from 1.5 to 0, they're going to have 3 different paths. And they all share the same voltage, because there's none that's one after another. So they all have a voltage drop of 1.5. Make my cute little table again. 6, 7, 11 are going to be my resistances. But the voltage of 1.5 is the same for each one. I'll put it in there. They're going to have different flows. Now find the resistance. I can't just add them up. I have to do the whole one adding thing. 1 over 6 plus 1 over 7 plus 1 over 11, and then do 1 over that final answer. So you do 1 6 plus 1 7 plus 1 11th, and you do 1 over that. You get around 2.5. Cool. V equals IR. Do the I again. I get 0.6. So 0.6 amps is my total current. And it's going to be split up among those 3. So those 3 combined should equal 1.6. Sorry, 0.6. You can see how 0.6 goes into the group and 0.6 goes out. So the parallel's got the most flow, obviously. Do the same as before. I equals Q over T. And you get 8.3 seconds. Oh, wow. More flow with the same charge. That means the series is going to last longer. To find the current through the 6 ohm, I do V equals IR again. I get 0.25, which is going to be the most because the 11 ohm resistance can have the least amount of flow. Find the power, I'm going to do V times I because they all have the same V's. And I know that the 6 is going to have the most current, so it has the most power. So the 6 would be the brightest. So in series, more resistance is brighter. In parallel, less resistance is brighter. Now that's an ammeter. That's a voltmeter. I'm going to redraw my picture again. The ammeter is right above R2. So that tells you how much current is going through that path. The voltmeter is bridging those two. It tells you how much voltage is between those 2 points. So which resistance has the most current going through it? R1 only, because all of it goes through it. Which one's got the ammeter going to choose? C, just R2, because it's the only one's going through it. Which one's the voltmeter going to measure? E, both of them, because both are the same voltage.